Morning. My name is Monsuru Adeokundeji. I'll be teaching you modulation today in our telecommunication engineering. So, modulation in electronics and telecommunication engineering. Modulation is defined as a process of varying one or more property of a periodic waveform. This property could be amplitude, could be wavelength, could be amplitude, could be frequency, and could be phase. And this is called the carrier signal. We vary the amplitude, frequency, or phase of a carrier with a modulating signal, the original baseband information we want to send or convey from one place to another. So we define modulation as a process of varying one or more properties of a periodic waveform called the carrier signal with a modulating signal that typically contains information to be transmitted. Modulation of a sine wave transforms the baseband message into a passband signal. Now, you can make an analogy of a person wanting to send a naira note, for instance, from a from the ground floor of a three-story building to somebody in the next story or the last story of the building. If the person has to throw the naira note to the person, it will be difficult because of the resistance of the air. The naira note will just be falling back to the floor. But for you to be able to send it to the target person, you may wrap the money around a stone. So, in that sense, the actual signal, the information you want to send to the person, analogically, is the naira note, while the stone is a carrier signal. So we can liken the naira note as the modulating signal and the stone to what? Carrier signal. So modulation helps us to convey and transform our baseband message into a passband message. By the time you wrap it around the stone now, it's able to pass through the channel, which is the air in this case. So why do we have to modulate? We can simply narrow this to 3 points. So each of these can be further broken down, but 3 is okay for us. One is size of the antenna. If you do not modulate our signal, the antenna will be excessively too long and this will not be feasible. Another thing is, without modulation, there is no wireless communication. Radio communication is possible, that is, exploring unguided medium to convey information from one point to another will not be feasible, it's impossible for now without modulation. Then it will be difficult to prevent interference from other signal. Say you want to send signal, I also want to send signal, and everybody is doing that without modulation, then it will be difficult. And it's the modulation that enables us to assign certain portion of channel to different individual, different devices that sends and receive signal. So let's look at this briefly more in detail. Size of an antenna. Antenna size, effective length of an antenna is proportional to a quarter of wavelength of the signal we are sending. So if you look at the relationship C is F lambda, we can conclude that our lambda is C over F, where C is the speed of light in here, or electromagnetic wave all have this frequency, this speed 3 times 10 raised to power 8. So we can simplify it as wavelength will be 3 times 10 raised to power 8 over frequency of the signal. But the audio frequency, the signal that can be detected by human ear, is between 20 Hz to 20 kHz, which is 20,000 Hz. So any frequency outside this range is not audio frequency. Now, if we use the formula lambda is 3000 times 10 to the power 8 over frequency, It means if you are using the highest frequency possible, which is highest audio frequency possible, which is 20 kilohertz, that is 20,000, which is 20 times 10 to the power 3. You divide that, you get 15,000 meter, which is the same as 15 kilometer. For us to erect that, sorry, this is the minimum wavelength. The length of antenna is about 15 divided by 4, which is 3.75 kilometer, or 3,750 meter. This is too long. If you have to do that, imagine the mechanical support that will be necessary to erect an antenna that is that long. Remembering that the stability of the body is directly proportional. Stability of a material or the system, the lower the center of gravity, the lower the stable the body becomes. So if the body now has that very long, and that means the base will be has to be so very wide. So it means it's going to take an excessive amount of land. So that's not feasible. But since we know this is not feasible, we cannot build such a very long antenna. A high frequency carrier, e.g., 1000 kilohertz carrier can be used. If you use a carrier of 1000 kilohertz, which is let's say 100 kilohertz for instance, we will be having uh, 100 kilohertz. Okay, sorry, we say 3 times 10 to the power 8. So 1, 2, 3, 1, 2, 3 will cancel out, 1, 2, 1, 2 will cancel out, and we are having 30 meters. So 1000 kilowatts at carrier. This is still correct with what I have here. So that will be 30 meters. So 30 meters, if you divide by 4 for the effective length of antenna, that's 7.5 meters. This is relatively easy to do. So you can see antenna as long as even 30 meters in some cases. So relative to the one we talked about earlier, we will see that this is easy to build. You've seen antenna even longer than this. So without modulating a signal, so antenna will not be feasible to build. So that is one thing. And we know that antenna, we have transmitting and receiving antenna. We'll discuss that more in detail later. But in this case now, we are limiting ourselves to transmitting antenna. Now, another point is wireless communication from the word wire. That means if you have a guided channel, the cable from the transmitter to the receivers are still connected in a way. But when you have a wireless system like a mobile phone, you don't have to, unlike the landline, that you have a cable that will connect your device terminal, and there's a connection through to the PSTN, to the service provider. But in this case, there is no connection at all or whatsoever. So it is by using modulation to transmit the signal through space. By using modulation to transmit the signal through space to long distance, we have removed the need for wires and communication system. So it's because of modulation that we can have wireless modulation. Technique of modulation helped humans to use wireless equipment in a big way in their life. Then phone no longer had to remain plugged to a wall. All the benefits of modulation has raised our standard of living in a very considerable manner. Then channel assignment. You know, since we say everybody cannot just be sending signal anyhow, but if you send and I send, it will be difficult for receiver to determine which signal he wants, because we all transmit using the same frequency. But by modulation, we'll be able to assign a particular channel. So there is a body that does that. If you want to set up, say, a radio station now, or a TV station, you'll be given a particular band of frequency on which you modulate your signal. So by doing this, interference from signals other than your own are minimized to a very considerable level. So there's no way see to tell your signal apart if there's no modulation. So by using a carrier wave of high frequency and allotting a band of frequency to each message, there's no mixing up of signals and the received signals are almost noiseless. So we'll, next class we'll be talking about uh, types of modulation, and we'll narrow it down to analog amplitude modulation. Have a good day.